I will start in a risky way. A definition is risky because it's often thought as boring. So please, let's concentrate. Sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. I would like to analyze this very quickly and identify key concepts. So for me, one key concept that comes through, it's not really explicit, is limited resources. Because you cannot avoid compromising future generations unless you acknowledge the limit of the resources you're using now. A second key concept is not easy to spot. The second concept is right there. It's a number. It's a date. This definition is not one that was coined a few years ago. It's 1987. I mean, in 1987, guys, I was young. In 1987, I didn't have children. In fact, we're talking about future generations here, aren't we? So the date is very important, actually, in this definition. And I talk much more about dates later because the dates bring a message. And the message is, if such an amazing definition was coined by a very important commission delegated by the United Nations, such a long time ago, why are we still talking about this today? What has been done since then? So let's look at it immediately. After 1987, a lot of work was done in order to release these goals, which are called the Millennium Development Goals. The Millennium Goals, as the name suggests, were launched in the year 2000 and lasted until 2015. One major criticism of these goals is the following. They are very anthropocentric, because apart from number 7, all of the others were very much based on the human figure, on society, and on those anthropogenic issues. Number 7 is actually probably one of the few MDGs according to which no progress was made, because some progress was achieved in some of the others. For example, if we look at achieving universal primary education, some progress was made there. Also, in promoting gender equality and empowering women, although you may disagree, but some progress was made there. Reducing child mortality, etc., etc. So what happened at the end of these MDGs in 2015? Well, a lot of thinking, a lot of examination in order to then come up with new goals, and these are the famous SDGs released in 2015. You see, instead of having 8, now we have 17. Instead of having only one that is based on the planet or the environment, we have a bit more. So we consider 13 based on the planet, climate action, and also 15 and 14 that have to do with life. However, people still criticize these SDGs as being very anthropocentric. If you were to study them in detail, to go beyond just the pretty graphics, but read the targets behind each SDGs, you would probably agree that to some extent they're still anthropocentric. So what is useful is another type of representation and analysis that follow the SDGs. I'd like to start with the BBC graphics, which is shown here. And basically, the title is Human Society and Their Increasing Environmental Impact. So this is interesting because it places human societies and the environment next to each other. The graphics on the x-axis goes along some kind of time scale. So basically, we go from when humans were hunter-gatherers to agriculture, to mercantile capitalism, industrial capitalism, and now consumer capitalism. At each stage, what you see is that we have three things happening at each stage. We have more people, the human population is increasing. We have more knowledge being accumulated, which should be very good if we were to use it wisely. And we also have more energy being used. The global environmental impact is greatly increasing. So this representation of the global challenges with the SDGs, it's very interesting indeed. And what this gave rise to is a new kind of concept which is called planetary boundaries, defining the limits of the system in which we live. And the planetary boundaries are represented by these graphics. So what are these boundaries? For example, fresh water use, or climate, or biosphere integrity. And there are more. I cannot go into details because it's going to take time. But the graphics is really important because, once again, it places society, so the human aspect, and the planet at the same level, not anthropocentric, okay? The colors show areas in which we are in danger, areas of great problem, where we are impinging on the boundaries of the planet. So, for example, you see here the biochemical flows, biogeochemical flows of phosphorus and nitrogen. We have major problems there. And that actually has an impact on agriculture because nitrogen and phosphorus are the so-called fertilizers, unfortunately used mainly from the chemical industry, petrochemical industry, that fuel agriculture. In some cases, there's no color, well, because quantification needs to take place at the global level, so a lot of work and research is still going on there. But the planetary boundaries should be taken into account with the SDGs. Now, this is the new vision for the way forward, okay? So what I will do, I will change the pace a little bit because of you. You are scientists. Therefore, I would like to highlight how important your role is and make you feel really important or really responsible or really bad. It depends on your consciousness in the next 20 minutes. In order to achieve the SDGs, if you were to look at these, you will realize that science is absolutely essential for innovation, for technology, for solutions. If you think about energy, if you think about climate, and I can go on and on and on. So let me just summarize. The role of science is fourfold, as far as I see it, is to produce new knowledge, and this should be very easy to understand. It should be that you can, with that new knowledge, hopefully you can explain mechanisms and phenomena and changes. You can identify solutions and propose novel technologies. Perhaps most importantly, you can educate, you can guide, and you can sensitize. Who? Well, anyone. Your kids, for a start, your students, society, whole nations, ideally. I would like to use climate, the SDG on climate, as an example to demonstrate to you how important science is. Now, science produced in the past few decades a graph that everyone should know, every citizen of this planet should know this graph. This is known as the Keeling curve, and it shows how CO2 concentration has been changing since this very precise monitoring started by Dr. Keeling in a weather station in the Hawaii, in the middle of the Pacific. So basically, especially if you're a scientist, in my opinion, you should understand and know about this. Because you should know what it means, 400 parts per million. You should know that that's way beyond 350, which is the safe level. You should know basically what it is. I'm not a climatologist. I'm not an atmospheric chemist. I'm a biochemist. I worked on proteins. I still understand this, and so can you. But now let's take this a step further, because people have been talking a lot about CO2. However, science has also shown something else. There are many greenhouse gases, CO2 is just one of them. Take methane versus CO2 as a greenhouse gas. Methane is over 20 times more powerful than CO2 in its heat-trapping ability. And again, science has shown this, not today, not yesterday, not last year. It's been known for a while, the physics of this. But not many people talk about methane, right? When you hear the IPCC, the Intergovernmental Panel for Climate Change, they seem to focus very much on CO2. I don't hear them talk about methane, but you as a scientist should know. Because you're rational and you're logical. And numbers guide your rationality. These are numbers. So let's look at methane. I'll give you 4 examples of how science is producing new knowledge on this particular topic. Example number 1. What is causing the rapid rise in methane emission? Rice fields. A nice study was published on this. Second example. Methane emission from cattle are 11% higher than estimated. Plenty of research work going on there. Example number 3. Dr. Royer shows the plastic pollution, especially on seashores and beaches, because of the UV radiation. Some plastic can be a new source of a warming gas, which is methane. Example number 4. The permafrost is thawing faster than expected and releasing large amounts of methane. So methane is a greenhouse gas. According to these 4 studies the science is producing, is clearly a very important gas that should not be underestimated. I'm sure you understand, and I've convinced you and proved my point, that science can produce new knowledge. And with that new knowledge, science is also explaining mechanisms. Now, what I want to do, I want to take this further and pick one of those 4 examples and show you how science can actually lead to solutions and can educate. Okay? So let's take one of those 4 examples. And the one I'm going to pick is the one of methane emissions from cattle. Okay? Why am I choosing that one? Well, to be very clear soon. Here is another example. Avoiding meat and dairy is the single biggest way to reduce your impact on Earth. Why? Because a cow releases between 200 and 500 liters of methane per day. That depends on the cattle, on the cow, how big and which sort it is and what food the cow is consuming. I don't know where you come from, but sadly, I know that where I come from and where I live, cows are used for milk, for dairy, for cheese, for yogurt, for cream. And if I go to a supermarket, the aisle of the supermarket for dairy is probably one of the most depressing places on this planet right now. Not to talk about all those people that eat beef. Now, what is great about this is that very recently, people have actually gone beyond that and look at the dietary footprint. What you eat has a footprint. Your choices of food have an impact on the planet. So what you can see here, potatoes, apples, asparagus have some impact. Chicken isn't actually so good as these, but compared to cow, is very, very bad. So, of course, people can choose. This shows how knowledge from science is guiding and educating people, potentially. Most importantly, and finally, Just a few days ago, if you were to look at the date, 8th of August 2019, the UN issued a fantastic report officially saying and admitting that eating less meat is going to have the most important impact on the fight against climate. Therefore, this proves my point that scientific knowledge can go all the way through, if it does, to education, to guiding and to sensitizing people. Because science speaks the truth, perhaps not always, but I like to believe that most of the time it does. Okay? So please remember this. Why? Because you're scientists. Okay? Sadly, it is not always the case that we can succeed to educate, guide, and synthesize. Sadly, very often, the knowledge stops at the theoretical level of explaining. Because there is a huge problem. You see, the connection here is a disaster. There is some kind of incommunicability because they speak a different language. The scientist speaks a very detailed, focused, specific language. The narrow focus on a very minute area of knowledge, of problem. You know, I know very well. I spent years studying the protein structure of a particular molecule, whether, I mean, you know, while the policymaker has other priorities, perhaps often dictated by economics. You can understand why these two worlds clash or do not communicate. I'm going to give you two examples to show a successful story to prove to you that it can happen, and then a one not successful story, which is just really the tip of the iceberg. So let's start with a good one, just because I feel, you know, positive. In 2017, almost exactly 2 years ago, Kenya brought about not the first, because other countries already had done that, but the toughest ban on using plastic. I believe this is an example not only of political will, but also of insight, of vision, based on science. Okay? Now, 2 years on, there's been also follow-up. Here is an example of 2 years on. So has Kenya plastic bag ban worked? Since the ban, the government says 80% of the population have stopped using plastic carrier bags. Just one aspect, but there's other plastics in other sectors. This is remarkable. Let's read a bit more. A study supported by NEMA found that more than 50% of cattle near urban areas were found to have plastic bags in their stomachs. Which is a bit funny after I've been slating cattle before, that now I feel, you know, bad for the cattle with their plastic in the stomach. But yeah, I mean, so really it was highly, highly urgent and necessary to take action. And that's just an example. I mean, we talk about cattle. Why? Because people care about cattle and they are related to food, as we talked about before. Now, the second example is not a good example. It says here, the scientists understood the climate 150 years ago better than the head of the Environmental Protection Agency. Pruitt denies basic science that we have understood for over a century. So when I showed this in the past, people then at the end raised their hands and said, but don't you think that's an exaggeration, 150 years over a century? And they thought, oh, it's journalistic license for exaggerating. And so I thought I increase my presentation a little bit by giving you some insight into the past, into the scientific achievements of the past. Who amongst you is a chemist? Oh, I have two takers here. Fantastic. You'll be very pleased to see the next slide. We have Arrhenius. Are you excited to see Arrhenius?
Yeah, depends on what follows. Yes.
What follows will satisfy you completely. What follows is the equation, the Arrhenius equation, which is probably the best equation in chemistry, right? An equation where what you see is the rate constant related to the activation energy. I mean, it's one of the most beautiful equations. Well, Arrhenius, of course, won the Nobel Prize in 1903. But before that, Arrhenius worked on a number of other topics, and let me show you one paper he published in 1896. Here is the paper. It doesn't look particularly attractive because, you know, it's old. 1896, Philosophical Magazine and Journal of Science. Here is the title. Let's read it together. On the influence of carbonic acid in the air, which is carbon dioxide, upon the temperature of the ground. In this paper, Svante Arrhenius, well over a century ago, predicted that the large consumption of fossil fuel that had already started by then would have an impact on this planet. He concluded that it wouldn't be so bad for Sweden, the guy is Swedish, because he didn't like the cold, but it would have some tremendous outcomes for other parts of the world. This was 1896. Now, let me take you 120 years after that. 120 years. Here is a paper in Nature Climate Change, as you see, 2016, okay? And what does it say? The climate response to 5 trillion tons of carbon. What does that mean? If we were to continue burning fossil fuels that are still in the ground, we would release 5 trillion tons of carbon. The paper brings forward the same science as Arrhenius' paper, only that it's a different twist, it's got more modern techniques, more modern tools, more accurate data, but it's the same message. The message is disaster. So, clearly science has been finding out facts and numbers for a long time on one of the SDGs. And that long time brings me back to our date that we started from. Whether it's 1987 for the definition of sustainable development, or whether it's 1896 for Arrhenius' paper, we seem to have a problem that the science is not acted upon. So I want to emphasize this a little further. In 1992, the International Union of Concerned Scientists published a paper, an alarming paper, World Scientists Warning to Humanity. In this paper, they identified 9 so-called mega trends, which I'll show you later, which have become classical sustainability indicators, indicators of sustainability and sustainable development. Not anthropocentric, of course, because this is pure science, it's not other things. And if you go to the website of the Union of Concerned Scientists, the 1992 warning, the page starts like this. The interesting thing is that a number of years later, because 1992 may be a while ago, so let's go forward to 25 years later in 2017. What happens? World Scientists Warning to Humanity, a second notice. What do they do in the second notice? They take the 9 megatrends previously identified and look on the progress. So should we have a look at the 9 megatrends? In the graphs, it will be hard to see because it's 9 squished together, but you will see a thick black line that's up to 1992, and then after the black line is from 1992 to 2017. So this is the paper in Bioscience about the second notice in which these graphs are published. So let's look at the first one. The first one is really lovely, and it's probably the only one that is so lovely. It's ozone depleters. Well, thanks to a good international agreement, those chemicals responsible for ozone depletion were prohibited, they were removed, and so you see that the line here, the thin line, up to 1992, and from 1992, it's great. This is a really good mega trend. So we see fantastic progress from 1992 to 2017. But if we were to look at the others, they're kind of a little bit concerning, a little bit, just to be funny. Freshwater resources, they go down. Dead zones, they go up. Forest goes down. CO2 emissions goes up. Temperature change goes up. Population goes up. Oh, look, population of ruminant livestock. Oh, why is that there? The scientists know that's why. Okay, so now, I think the 9 megatrends just show you now really prove the point that we have a major failure with this communication between scientists and policymakers. That's why in the next slide I would like to underline the role not of science, but the role of scientists. This is where you come in. I think scientists should keep an open mind, and they can, as well as have a wide perspective. Although very often with your research you have a narrow perspective, but you have the ability of keeping a wide perspective. Scientists can educate and can communicate. Do not underestimate the power and potential that you have to educate your own students beyond that particular course that you're meant to teach them. It's up to you. Scientists can be a role model. Why? Because they have the understanding, the foresight, the vision. Finally, they have a moral and social responsibility. You may disagree, but here is a man that doesn't think so. Konrad Lorenz said that we live in an age in which it is the scientific researchers who are able to see specific dangers quite clearly. Therefore, they have a duty to speak out. That links to my point of responsibility. It's easy to think, oh no, I'm a biochemist, I don't know anything about climate. Nevertheless, if I really want to, I can understand those graphs and I can communicate them to my daughters, to my friends, to my class. Education is extremely important. In fact, from 2005 to 2014, the United Nations declared a decade for education for sustainable development. It was called ESD, Education for Sustainable Development. So ESD is very important. It was led by UNESCO, and it really produced a number of good documents that can be used in a number of classrooms from high school through to university. Sadly, not many countries adopted this. To my knowledge, Chile is the only country that really took on board and embraced some of these initiatives. However, education is extremely important, and here is a statement from the United Nations as a part of the ESD initiative. In order to halt the current model of unsustainable development, societies must work on a change of mind, on a change of behavior. To do that, you need education. Wise of the scientific knowledge. And in fact, UNESCO adopted that, the meaning in that quote, by this graphics, this logo, which is very nice. Let's change minds, not the climate. Because we're changing the climate, we should be changing the minds to change the behavior. And it is possible, of course it is. Progress, said Professor Shaw, is impossible without change. And those who cannot change their mind cannot change anything. So I hope you feel this, because we should all use science to change our mind, our behavior, and also the mind and behavior of those around us, whether we start small or large. So please look at the Sustainable Development Goals in a new light, if I have succeeded in any way to provide any minimal inspiration. And please do go beyond the SDGs in terms of the colorful graphics. Look at their targets. Each SDG has specific targets. Start with one that you feel most passionate about. Perhaps it could be quality education, as we talked about education, or next to it, gender, okay? But there are others, climate, of course, and energy, and you can pick many. The most important one, let me tell you, let me just conclude with this lovely challenge. What do you think is the most important of the SDGs? Or my favorite one? Education, you say education? It could be, but just to make life complicated, I say no. On this occasion, I'm going to challenge you more.
17, partnership for the all goals.
That's also very interesting indeed. But once again, you know, I'm really provoking you here.
Reduced inequalities because like women are, if not more, there are more women than men. And if it's not done together, then there is not a holistic perspective to move forward.
I don't disagree with you at all, at all. You are all right, but that's still not my favorite one. Yes, but she's cheating because she probably knew it before. She knows me very well. But guys, number 12 is probably the most underrated of SDGs. And what is it about? It's about changing your mind and your behavior, taking responsibility for what we consume. So please remember there are only two paths, BAU, business as usual, but we need to change our mind and behavior and the way we think to go towards another better path. Hopefully it didn't take too long. No, it looks like we're in good time. So thank you for your attention and the participation. Any questions? We might have a couple of minutes. This smartphone is the first one I've ever had. If you were to look at it without a microscope, but by close by, you would see that there are signs of wear and tear. It's probably fallen down a few times. The paint is coming off. It looks like it's being smashed. But, you know, it works. It's not particularly beautiful. It's not an iPhone or anything, but it works. It still works. There's nothing wrong with this phone. Nothing. So my question was, to all of you who has a smartphone, which is your second smartphone, was the previous one, just like mine, still working well? In most cases, the answer was yes, it was still working well. So why did you get a new one? Oh, my dad, my mom bought it. Yeah, whatever it might be. The truth is, why would I want a new one? Well, because this is kind of small. I want a big one. Or this is perhaps, I think it's slow. Simply, I want a new model that looks flash, that looks fresh, that looks fashionable, that looks whatever. We are bombarded by inputs by the media to consume. And this is why I think if the United Nations did any decent work with those SDGs, that particular one is the one that is most interesting, because more than half of our lives are driven by consumerism. You know, if I listen to the radio, I don't have a TV, but if I listen to the radio, how many adverts are like, oh, it's time to buy a new bed. Oh, it's time to renew your kitchen. Oh, it's all new. So it doesn't matter if, you know, for me, I look at my stuff, I could buy a new phone. Why? Because this is old, but, you know, I want a new one. Buy a new computer. Yeah, because, you know, my computer is also 10 years old. I could buy a new car. Why? Well, because it's always nice to have a new car. And you go on like that. But so many people live exactly in that way. So in answer to your question, why? Is because the economic, social systems that we live in are driven by consumption. And the result is also waste. Responsibility means that before buying this, which I apologize, it started making noises just to prove that it's working very well, but let me turn it off. You're very nice, you like my jokes. Nobody likes my jokes normally, so I really appreciate you laughing. Responsibility means this: if I buy a new one, I must know where the components of this phone are coming from. I bet most of you, just like the kids I was talking to, don't know that inside here, amongst the various metals and minerals that there are, is one called coltan. C-O-L-T-A-N, coltan. Coltan is present in large amounts in Congo and is mined, amongst others, also by children. And there are plenty of documentaries about this. However, most Westerners have no idea that in their phone, and their phone works only because of the coltan. Why? Coltan is extremely efficient to make condensers that are tiny. There's no other material that works as efficiently as that. So coltan is very, very useful for making these devices. But everyone should know, if we're using anything we use, but the problem is we don't know normally. We don't know. We ignore so much detail. But this is science. This is technology.